So let's look at that second graph. We've got a second graph here where we have y equals e of x. And what we want to do here is we want to work out the upper rectangles. So last one we looked at was the lower rectangles. This time we're going to be looking at the upper rectangles. Same process as before. However, we're going to call this here the right end point. So that means that we'll start from the right hand side. And the right part of the rectangle touches the curve. So the right side part of rectangle will touch the curve. So the last one we looked at left hand. So we started from the left hand side touched this curve. This time it touched starting from the right. So let's put some context into this and get straight into it. So we want to find the values of between x is equal to 1 and x is equal to 2 this time. Okay, and how many rectangles do we want to have? We'll have 3 rectangles. So 3 rectangles. So just like that last example, the first thing we have to do is we have to find that width. So the width, recall, is the difference between these two divided by how many rectangles we have. So 2 minus 1 divided by 3, actually, is that 2 minus 1? Yep. I'll go to 0, sorry, we'll go to 0. Start at 0. So 2 minus 0 divided by 3 is equal to 2/3. So each rectangle is going to be 2/3 each. So let's put this in. So we've got about half here. Let's call that 2/3. Add another 2/3 on. I'm going to probably get like 4/3 here. Let's move it over a little bit. Okay, and then another 2/3 is going to give me 2. Okay, so let's now sketch this graph. We're sketching from 2, from the right to the left. So the first thing we put in here is, let's mark 2 in there. Okay, our next mark here will be 4/3 and then 2/3. Now, because we're doing upper rectangles, that means we're going across and down, across and down, across and down. So in this case, just like when it comes to the lower rectangles, it's the side that we're looking at that touches it. So this time it's right end, the right part of the rectangle touches it. Okay? Because it's upper rectangles, it means that we're going to be going over above the graph. And even if we had the graph going in the opposite direction, we could still do that thing. As long as if it's upper rectangles, the right hand side is going to touch it. If it's left rectangles, the left side will touch it. Now, just like that last example, I now need to work out, well, what is the area of this going to be? And I need to use these points here again. I need to work out, well, what does that equal when x equals each of these? And I have that formula up here. So if I had in my equation here, just for this one here, we'd have y is equal to e to the power of 2/3. Okay? So that gives us approximately 1.95. What else do we get? We get 3.79 and 39, I think. 7.39. So these here are the right-hand points of an upper rectangle. So if we were going to find the area is now equal to the width, which we know is 2/3, times each of these points that touch the right angle. So 1.95 plus 3.79 plus 7.39. And if we plug that into our calculator, let's see what we get. So 2/3 brackets 1.95 plus 3.79 plus 7.39. We get 8.75 units squared. So let's just sum up what we've looked at here today. We've looked at the lower rectangles, and the lower rectangles was telling us that it's going to give us an answer that's less than this. Okay, so it's going to be underneath the curve, where the upper rectangles are above the curve. So we're kind of getting more than we need in terms of this. And we could look at combining the two and trying to find a difference between the two in terms of upper and lower rectangles, but we have another way of actually getting that exact answer, and that's called definite integrals, which we're going to look at next. So when we sum up, upper rectangles, another way you can call it is right-hand point, and that means the right-hand side of your rectangle will touch that curve. So that's where you'll calculate with the corresponding x values what they will represent. We start from the right-hand side because it's right-hand, and we want to make sure that we find our width first. Upper and lower rectangles to use with integration. Lots and lots of fun. Lots of practice as well. But if you think about the left hand starting from the left and the right hand starting from the right, it kind of makes sense. Alrighty, next video we're going to look at is indefinite integrals. See you there.